So Assalamualaikum and good afternoon. So welcome back to class Engineering Maths 1 at F1013. And this week we will combine this class with other class from Dr. Tay. So and in future there will be also integration chapter that will be conducted by Dr. Tay. So I will take over the differentiation part, and then chapter the integration will be conducted by Dr. Day. And in between week 13. So today is week 9. So last week is week 8. So the first week for our, I think last week is week 8, right? If I'm not mistaken. So now is week 9. So week 9, we do a combined class. And the combined class is only for Thursday, 12 to 2 p.m. Okay. And another class for your class, let's say for my class, I have Monday, 8 to 10 a.m. And Dr. Tay class, I think, is Friday, 4 to 6, right? So that class is conducted by your own lecturer. And maybe there will be a class or maybe a tutorial session or just you study alone. Okay, you study by your own. So for this chapter, differentiation, it will be in your test 2, and also there will be a test 2 also integration. So there will be 2 chapters for your test 2, integration and differentiation. We will conduct it on weekend, week 13. Okay, so we will find a time that all of you are available and can what available and also can answer in your preferred time. So maybe around morning or maybe around evening or weekend, maybe Saturday or Sunday. I think maybe Saturday lah. So then you need to have your computer on, and also you need to have your Wi-Fi or internet connection very strong. Otherwise, you will lose your connection. So for those who are not have good strong connection internet, so you may try to go to your library. If the library, okay, library maybe in your place, or maybe try to go to your uncle or auntie house. Okay, just for that certain time for examination. So we need to have the condition is very conducive for you to take exam. And the question and answer is posted in eLeap. There will be a time taken, 1 hour only, and then you need to submit within 1 hour. Okay. That is for test 2, just for your preparation, early preparation. Okay. All right. Okay, so today we will cover chapter 7. I think we just refresh back our prior knowledge on differentiation. And I hope all of you semua dah biasa pun dengan differentiation kan. So just refresh and also kita belajar balik about the differentiation. Okay, so differentiation it is a first order derivative of fx. So the first order derivative for the function we call as fx, where x is equal to a, so defined as f prime a. This is actually the derivative, f prime a equal to limit h approaching 0, where f a plus h minus function of a divided by h. So provided that this limit is exists lah. So if the limit is exists, we say that the f is differentiable at x equal to a. So untuk lebih mudah, the process of computing a derivative called as differentiation. So selalunya kita guna differentiation ni guna notation of df over dx ataupun dy over dx. Okay, depends on the question. If y is equal to something something something, so dy is over dx. Or if function fx equal to 2x plus 3x squared and so on, so that will be df over dx. Ataupun we can use f prime x. So this notation is usually used in differentiation. Okay. Then there is some example. So we use the definition to find f prime x, where the function of fx equal to 2x squared plus 1. So you have this function 2x squared plus 1. So from here you need to differentiate. So the f prime x is actually, okay, this is from the definition. F prime x equal to limit h approaching 0. So fx plus h minus fx divided by h. So f prime x equal to limit h approaching 0 to, so you using this,
Lipun nak dengar deh.
okay. So using this definition, 2x plus h squared plus 1 minus dengan fx is 2x squared plus 1, 2x plus squared plus 1 divided by h.
Apa yang aku boleh bilang yang belajar ni bunyi gitu.
Okay, Angelia. So now f prime x equal to limit h approaching 0 to x squared plus 2x plus h squared plus 1, where you get here is from the x plus h u squared, so you get this equation. Okay, then this is from the fx itself is 2x squared plus 1, so you have 2x squared minus 1, so divided by h. After that, okay, you expand this as an equation, 2x squared, you become 2x squared plus 2 times 2x as h, x h, so you get 4xh plus 2h squared plus 1 minus 2x here and minus 1 and divided by h. After that, then you rearrange back, you will get, here you can cancel out 2x squared cancel out dengan negative 2x squared, and then plus 1 cancel out with negative 1. So you will get this equation only 4xh plus 2h squared here over h. Then hash here also you can cancel out. Then you only get, you kecilkan, you mudahkan, okay, simplify this equation into h, then you will get 4x plus 2h, where actually is equal to 4x. Okay, sebenarnya ini cara yang definition tu lah. Okay, kalau mudahnya fx, differentiation of fx to x squared plus 1 ni senang je kan, 2 darab 2, 4. So you dapat 4x. X squared minus 1 tu kan. So itu cara definition. Okay, how it is derivative. Okay, contoh ni pun dia nak suruh guna use the definition. Kalau use the definition, you must use this definition is this one. Okay, kalau cara mudah, you just differentiate from equation. Kalau you just differentiate from this equation, this example, you get, what you will get, you will get 3x squared plus 2. Okay, you will get 3x squared plus 2. So after you differentiate this equation, but if you use the definition, you must use write up like this one. Okay, Now we go to basic rule of differentiation. So in differentiation, actually there will be some basics rule that we need to remember. Okay, the first one is constant multiplication rule. Okay, there will be, I think, 4 rules for you to remember. I think just a refresh from your prior knowledge. Okay, so y is equal to fx and k is constant. So this constant is the constant multiplication rules. So let's say you have y equal to fx and k is constant. So you differentiate the function y, so you get d ky over dx, ataupun you boleh keluarkan k, you take out this k in front the differentiation part. So k is the constant, put k in front of the differentiation part, then you differentiate the y function. So k dy over dx equal to, you say, then you get k dy dx, or you can write down as k f prime x. So this is the part of that you will differentiate. So the k is constant, you just take it out and put in front the differentiation. So for example, given y is equal to 5x, okay, given y is equal to 5x, so you need to find the derivative of 2y. You find the derivative of 2y here. So y is 5x. So what is derivative of 2y? So 2 is actually the constant, the multiplication of constant. The constant is 2, and the function is y, and y is actually 5x. So these two you take out in front the function y, so you just differentiate the function of y. So y actually is 5x. You differentiate 5x, you will get 5. Then 5 times by 2, then you will get 10. Okay, dy dx is actually 5. You differentiate this function y. So you differentiate the function y dy dx, you will get 5 only. So 5 times the multiplication of constant, then you will get 10. Okay. It's very easy. It is a multiplication. So let's say if you have here 6y, so mean 6 times by 5. So let's say if you have here 5x squared, you need to differentiate 5x squared here, and you will get what? You will get 10x. So here we will change 10x. Okay, what 2y you will get 20, 10, 20x. Okay, that is example. Okay, so that is the first rule. The second rule is sum rule. Okay, sum rule. Sum rule, if two functions are differentiable, then the both function can be dealt with separately. So mean, let's say if the sum rule here, fx plus function gx, fx plus gx, you need to differentiate this function, both sum rule. So you may separately both function. Okay, let's say for first function you separately differentiate, then second function here you also differentiate separately. So function fx you differentiate separately, function gx also differentiate separately. Okay, whether it is positive sign or negative, whether it's plus or minus. Okay, if minus, you just change it to minus. So even it is the same method, you need to differentiate each function. Okay, ini contoh fx dengan gx. Okay, contoh saja. Contoh kalau kat sini 2x squared minus dengan 4x cube. So you kena differentiate each function. Okay. So for example, So example 1 here, y is equal to x for x power of 4 plus x squared. So there will be two functions. Okay, y equal to x squared. This function you can actually differentiate. Okay, simple differentiation macam biasa. 4 bagi depan, 4 minus 4x, 4 minus 1, so you get 4x power of 3. Same goes to this function, x squared, so 2x, you will get this one. Same goes to this one also, x squared, x power of 4 minus x squared, you will get 4x power of 3 minus 2x. Okay guys, so this is a simple basic rule, which is the rule of sum rule. The third rule is product rule. Again, a product rule, if f(x) and gx are differentiable at x, it is possible to differentiate f(x) dot gx. Products mean you multiply the function fx to function gx. Okay, so let's say if the given function fx dot gx, then you need to use this rule. Okay, I think this is the popular rule for you to remember. So function x, you times by the differentiate of function gx plus function gx times the differentiation of fx. Ataupun lebih mudah, you write down like this, fx dot gx prime equal to fx g prime x plus gx prime x. Okay, just hilangkan saja, dan tambah. So this is product rule. So when you get the example of product rules, okay, contoh, y is equal to 4x squared minus 1 multiplied by 7x cubed plus x. So this is, you denote as fx, so you denote here as gx. So if you follow this rule, so fx times the differentiation of gx here plus gx times the differentiation of fx here. So you write down the differentiation dy over dx equal to, this is fx, right? So fx 4x squared minus 1 times the differentiation of this part. This part, when you differentiation, 7 times 3, you will get 21. Power of 3 minus 1, you get power of 2. X, you differentiate, you get 1. Okay, nombor bulat. So this part complete. Plus another part here is gx. Gx is this part. 7x cubed plus x. Then you need to differentiate this f function, this part. So you will get 4 times 2, which is 8. X squared minus 1, you will get x. 1 you differentiate is 0 lah. Okay, because you don't have any x to differentiate. So you will get at x. So from here, you will get this equation. Then you rearrange back the equation, follow to the highest power to the, but not yet, okay? You times first, okay? You multiply first this part and also this part. So 4x squared times by 21x squared, you will get this 84x over 4. Then this part times by this one, you will get positive 4x squared. This part, negative 1 times 21x squared, you will get 21, negative 21x squared. Negative 1 times 1, you get 1, negative 1. And same goes to this second part. Okay, kalau multiplication, product rules. After that, you rearrange, follow to the highest to the lowest power. Okay? So you will get 140 x x power of 4 minus 9 x squared, okay, minus 1. So this is your final answer. Okay, alternatively, for this example, you can multiply the terms and differentiate in a normal way. Okay, so cara yang lebih mudah yang mungkin you boleh guna cara lain. But this is how it is product rule function. Okay. Okay, example 2, if fx is equal to x squared tangent tan x, find the f prime x. So when it's come to tangent, sine, cosine, and so on, there will be trigonal function that you need to refer back. Okay, how it is differentiate. Okay, the rules of trigonal to differentiate. So using the product rule, so you have two function here. Okay, here is actually first part, and this is the second part. Let's say this is fx, okay, and this is the gx. So using the product rule, you know that f prime x is equal to fx times g prime x plus gx times by f prime x. Okay, so here this is the f prime f part, and this is the gx part. So when fx is equal to x squared, so this part you need to differentiate, so you will get tangent x differentiate, you will get second power, second squared x. Then the g part is tangent x, tangent x. Then you need to differentiate this part, which is 2x. Then you will get 2x. So this is your final answer for f prime x for this equation. Okay. Most probably final exam will find out test, they will be asking you one of two question on trigonometry. Okay, you must take note and then try to find what the differentiation for trigonometry. Okay, if the notes is if in your final exam is not given the derivative of trigonometric function, then you need to uh, remember. But I think there will be a table for you given in your final exam. Okay, so don't worry. But just for now, try to remember for a simple one. Let's say sine x, derivative for sine x is cos x. Derivative for cos x is actually negative sine x. Okay, the basic one. Okay, and tangent is second square. Okay, that is product rule. Okay, so we have four. I think we have four, right? Okay. Oh no. Okay. Yeah, four. Then the third. Okay, this is example of find the derivative of some example. This is also a product rule. Okay, one product, two products. So you need to do the fx and also gx. Same goes to this. Same goes to this example. 3x squared is fx part, and sine x is another gx part. So these two part you need to using the product rules. Okay, you may take this example and you may do this example. Okay, anyone can give the answer after this. I give you times to write to try to find this derivative by using the product rule. Okay, jadikan dia fx dengan gx. So ni first function is fx, the second function is gx. Then you just using this Basic rule, okay? Simple lah kan? Then you can get the answer. So for trigonal, here sin x here. So if you derive sin x, you will get cos x kan? Right? So try to do this example first. And I will choose someone to just read out the answer later. Okay? Randomly, I will choose anyone to answer the A and also B. Okay, I give you 5 minutes. Try to do this example. Before we proceed to the last rule, quotient rule. Okay, 5 minutes. Okay. So the first part is not really difficult. Okay, compared to next part later when we go to composite function and circular function. Circular function is actually the trigonal one, where we deal with the pi and also the circular, which is trigonometry. Okay, anyone get the answer for the example A? Maybe I can choose anyone from here, the list, the name, participant. How about Wakabib? Did you get, this A example? You may speak the answer. Or anyone who finished the example A, you may speak up. You can unmute your microphone. You may give your answer. Any? Not yet. Okay, thank you. Celine, thank you, Celine. So you get negative 24x power of 2 plus 4x plus 15. Anyone get the same answer with Celine? For A? Okay, thank you. Farhan, same. Okay, so then you will get the answer. Right, good. Then can you differentiate this part? 3x squared sine x. Anyone get the answer? You may chat or you may unmute your speaker. Okay. Same with Celine. Wait. Okay. So you get 6. Wait. 3x squared cos x plus 6x sine x. Anyone get the same answer? 6x sine x plus 3x squared cos x. Okay, good. Ada yang jawab 6x cos x. Jawapan dia adalah 6x sine x. Okay. Because you, which one ni? Wait, okay. 6x sine x plus x cos x. Apa yang jawapan ni? Aizat. So it is 6x sine x plus 3x squared cos x. Banyak jawapan. Macam jawapan yang berbeza-beza je ni. So the first part, 3x squared. You get cos x, right? 3x squared cos x. Apa jawab tu betul. Then you differentiate x squared. Ni. X squared ni you dapat 6x sin x sepatutnya. 6x sin x plus 3x squared cos x. Itu adalah jawapan dia. Okay. Kedudukan tu tak kisah. Tapi kalau paling bagus, you follow the rules lah. So you should get 3x squared cos x plus sin x 6 sin x 6x sin x. Okay, right, so that's that will be the answer. Okay, so you may try for those yang tak dapat jawapan tu, kena check balik rules. Sekejap So then the set, okay, alright. Thank you for those yang answer. Thank you. So jawapan yang sebenar adalah seperti mana yang saya cakap tadi itulah. Okay, follow the rules, then you will get the correct answer as same as the first one. Saya punya jawapan. Okay, betul. Alright. Thank you. Then quotient rule. So quotient rule, if fx and gx are differentiable at x for fx over gx and gx 0, then you will get this types of rule. So paling mudah kalau kita tengok kat bawah ni lah. So differentiation of quotient rule. So you get the function fx over gx equal to gx times by f prime x minus, okay, kena ingat remember kat sini, minus kat tengah. Okay, kalau bahagi je minus, kalau darab dia tambah. So kalau bahagi, quotient rule dia minus. So let's go to, dia terbalik dah dengan yang tadi. So yang tadi kita mula dengan fg prime x kan, dan tambah dengan gx darab dengan f prime x. Dan itu adalah untuk product rule. Tapi for quotient rule, you terbalik, you guna gx first, gx f prime x minus f prime g prime x divide by g function yang kat bawah ni kuasa 2. Okay, jadi lebih kurang sama dengan product rule, cuma dia tukar je, kita guna yang belakang ni tolak dengan yang depan ni. Okay, to remember So Ni minus fx g prime x divide dengan function gx kat bawah ni kuasa 2. Ini adalah dia punya rule. So, for example, y we have equal to x squared minus 2 over x squared plus 1. So, ni kan ada dua function fx dengan gx. So, this part awal-awal you boleh letak dekat bawah darab dengan kuasa 2. X squared plus 1 times by kuasa 2. So, find the dy over dx. So, remember the rules. So, the rule is x squared plus 1 darab dengan differentiation of f part and g parts kan. F part here, then minus f part darab dengan g part yang differentiation of g parts. Okay, divide by x squared gx kuasa 2. So x squared plus 1 power of 2. So when you do the rules, then you get x squared plus 1. So you differentiate this part, x squared minus 2, you will get 2x. So 2x minus, here minus, x squared minus 2. Then you differentiate this part, you will get 2x also. Then you will get 2x. Then you try to expand the equation. X squared times 2x, you will get 2x power of 3. Plus 2x, then minus x squared power times by 2x. Here you get same 2x power of 3. Then minus 4x. Then you can simplify your equation from this part. You just cancel out 2x squared, 2x power of 3 minus 2x power of 3. Then you cancel out. Then you will left 2x plus 4x. Then you get 6x. Then yang kat bawah ni, x squared plus 1, you can write down like this. Okay, x squared plus 1 power of 2. So then this is your final answer for differentiation of quotient rule. Okay. This is the fourth rule. Okay, go on. Okay, so example, show that again the function of tangent x over, okay, you will get secant square x. Macam mana nak tunjukkan? Okay, example then differentiate y equal to 1 minus cos x divided by sin x. Okay, so again this is your function fx and then gx. Okay, you may try to differentiate this part first. Okay, cuba buat example yang bawah ni. Okay, so try buat example yang bawah ni. So again, cos x kalau differentiate dapat apa? Cos differentiate you akan dapat negative sin x. Okay. Kalau sin x you differentiate you akan dapat cos x. Okay, try to answer this by using the quotient rule. So this is your first part, f part. This is your second part, g part. So try to answer, then you may share your answer in chat room. I give you 5 minutes also. Same, we use a quotient rule. Try to use a quotient rule, okay? Okay, anyone get the answer? Simple one, questions. Okay, check. Okay, wait, tangent, no, tangent x equal to sine x. Anyone? Tangent x equal to sine x cos x. Okay, 2, 1 cos x over sine x power of sines to x. Sine power of 2x cos x plus cos power of 2x divided by sines x power of 2. So here you will get sine x power of 2, correct? Okay, I think most of you get the same answer. So you will get sine x power of 2 minus cos x plus cos x power of 2 divided by sine x power of 2. Okay, that will be the answer. Thank you for those who are answering. Kadin, Ryan, Farhan. Okay, alright. Thank you for those who answer. Alright, so we continue. Differentiation of polynomial function. So when we talk about polynomials, means there will be n numbers here. Okay, x power of n and n x sama. Let's say x is power of 6, so 6x 6 minus 1. So this is the polynomial. So find the derivative of fx equal to x power of 3. So same, kita dah tahu juga cara untuk differentiate this function. So it is 3x squared. Kalau you differentiate the x power of 3. Okay, x power of 7, then you will get 7x power of 6. Okay, find the derivative of fx x power of 8 and gt where t is power of 107. So same, sama juga dia punya function tu. The rules is n x n minus 1. So you will get this function x dx f prime x of x power of 8, you will get at x power of 7. Same goes to gt equal to t power of 107, then you will get 107 t minus t 107 minus 1, you get t 100 power of 6. Okay, just a simple one. Example 3, a combination of equation that have a polynomials. Example, if you have y equal to 2x power of 4 minus 2x power of 3 minus x squared plus 3x minus 2, then you differentiate. You just differentiate each of this polynomial. Then you differentiate. Here you will get 8x power of 3 minus 6x power of 2 minus 2x plus 3. This one we get 0 because it's no x. Then the final answer we get this one. Okay. So the polynomial actually simple. Okay. You pun dah lalui polynomial tadi. Then go to the composite function, differentiation of a composite function. So composite functions, you have chain rule. Okay. First you have a chain rule. You have a chain rule. if you have y equal to f u and u is gx equal to gx, then y equal to f function of f gx. Okay, y equal to fu and u is gx, then you will get y f u here is gx, so function of gx. And the chain rule says that dy over dx, you not differentiate this one, dy over dx, this one, this part, equal to dy over, kalau kita guna ni, dy over du dot du over dx. So silang because you nak cancel out kan. So you intermediate of du here. So dy over du over dx. So this differentiation that use in change rule. Contoh, you have y equal to x power of 3 plus x power x minus 1 power of 5. So you let assume here as a u. So you let u equal to x power of 3 plus x minus 1. So ini adalah u. So you differentiate first u. So let u x power of 3 plus x minus 1. Then you differentiate u. You will get du over dx. Du over dx. Function u over function dx. You will get, differentiate 3x power of 2. And x differentiate dapat 1. Ni dapat 0. So you get du dx adalah. Now note that when you change this to u, so you dapat apa? Y equal to u power of 5. Betul? Because you let assume this to be u. So now it's u. So y equal to u power of 5. Okay. Ini adalah u power of 5. Okay. So when you get this one, ni you kena differentiate y in term of u. Okay, differentiate this y in term of u. So dy over du. So you get 5 u power of 4. Okay. Then you have this dy over du over dx. Then you can use this chain rule formula. So you have dy over du and you have du over dx. So you substitute in this part. So dy over dx equal to dy over du is 5u power 4. So 5u power 4. Du over dx is 3x squared plus 1. So you get times by, ni dot product is time. So times by 3x power of 2 plus 1. So before you not solve this, you must remember there will be u here and this one x. So what is u? U is, your assumption of u is x power of 3 plus x plus minus 1. So change back 5 u dekat sini, you change to the real equation, the assumption that you get from this one. So letak sini semula x power of 3 plus x minus 1 power of 4, then times by 3x squared plus 1. So you solve this equation. Okay, solve this equation. You will get 5x power of 7 plus 5x power of 4 minus 5 power of 5 lah kan. And then you can times dengan x squared plus 1. So you boleh solve the equation ataupun kalau dalam slide ni dia finish at this part. Okay, finish at this part. Okay, you can get another answer here. Kalau you expand this equation. Okay. Ni contoh basic kan, simple. But again, most probably there will be a trigo for differentiation and integration. Trigonometry part is very quite challenging. Okay, where you deal with cos and sine and also tangent. Okay, sometimes you will face difficulty to remember all this part. Okay, most of us careless on putting this minus sign, minus minus part. Let's say cos. If you differentiate cos, you will get negative sign. If you differentiate sine, you will get cos. Okay, that part is sometimes we are mostly careless, right? So again, if you have this trigonal part, let's say find the dy over dx if y is equal to 4 cos x power of 3. So how? Which one you want to assume to be u? To be u. Okay. So try to find the simplest part to be u is x lah. So this part is actually x power of 3 is, we can assume, let's assume u equal to x squared, x power of 3. So then you will get u equal to x power of 3. Then you differentiate this u in terms of x. Du over dx, you will get 3x power of 2. Then your y will be y equal to 4 cos u. Okay, 4 cos u. So y 4 cos u ini you need to differentiate in terms of u. So dy over du equal to 4 cos, again differentiate cos, you will get negative sin u. Cos u ni tak apalah, kalau cos x, kalau cos u differentiate, you get negative sin u. So you have these both differentiate part, then you combine into dy over dx. So dy over dx is equal to dy over du dot du over dx. Then dy over dx equal to dy over du is negative 4 negative sin u, ataupun you boleh letak negative 4 sin u. Then this part du over dx is 3x squared. So you just put like this, negative 4 sin u times by 3x power of 2. Dan you darabkan, you dapat negative 12 x squared sin again u ni you kena tukar. Okay. U kena tukar. So tukar u is equal to x power of 3. So change here, u is kat bawah ni you letak negative 4 sin x power of 3 kurungan times by 3x squared. So then you simplify this equation in term of x, okay? In term of x, because y in term of x. So you get negative 12 x squared sin x power of 3, x power of 3 because u is x power of 3. Then this is your final answer. Okay, hopefully this is clear. Okay, change rule. Alright. So you may try to find another derivative here. We just use we try to do example A lah, sama macam tadi, cuma itu. Example A, cos 3x squared. So mana you nak guna, where you want to find the u, which one is u, which one yang you nak letak u. So you ambil ni lah 3x squared ni adalah sebagai u. So cos u. Kalau ni dia cakap cos 3x squared. How about this one? Cos 3x power of 2. And how about cos squared times cos squared x and square root cos x? So there will be a different way to find, to assume which one you want to be, to make it as a u. Okay, alright. So your assumption is important for you to get a correct answer. Okay, for mostly for trigonal part trigonal part. Okay, you may do this example later in your home. Then also kind of example also A, ni just a review Kalau A you boleh guna quotient rules, and B you can guna product rule. Okay, just a review. Okay. Then come to another function, another differentiation. So kita dah go through differentiation rules. First kita go through with constant multiplication rule, sum rule, product rule and quotient rule. Then polynomial. Polynomial simple Bila sampai polynomial kita boleh masuk composite function. Composite function kita mostly kita guna change rule. Okay. Then kita go to differentiation of circular function. So circular function ni mostly we dealing with sine, cosine and so on lah. Okay, we try go punya part trigonometric function. Okay, circular function is more on trigonometric function. So considering the derivative of fx equal to sin x, from the definition we find that ni sama ni definition ni yang first slide tu dia guna definition. Bila dia guna definition dia guna cara yang this punya formula lah formula for definition. For the definition, f prime x equal to limit h approaching 0, fx plus h minus fx divided by h. Then you just substitute the value of fx here, which is sin x. Then you get sin x plus h minus sin x over h. And then you differentiate the part. Okay, then you get sin x cos h plus cos x sin h minus sin x, okay, over h. Then so on sampai habis. Then you get the part last, okay, ini cara last you get the simplest part is, thus we find that the derivative of fx equal to sin x adalah cos x. Okay, sin x0 plus cos x1, then you get the cos kalau you differentiate sin x you dapat cos x. Tapi dia punya proof how to by the definition panjang lah Okay, this is how they push to the definition through the definition. So we just write down d sin x over dx equal to cos x. Yang kita nak summarize adalah yang ni lah. Okay. Differentiate sin x equal to cos x. Differentiate cos x equal to negative sin x. Differentiate tangent x equal to secant squared x. You differentiate the secant, you will get secant x times by tangent x. If you differentiate the cosecant x, you will get negative cosecant x cotangent x. Then if you differentiate cotangent x, you will get negative cosecant squared x. So the most popular one part is this left part lah. The right part is rarely used. But this left part is usually we use in giving a question Same goes to integration later on. Same goes to the integration. But for the differentiation, it is like this. Okay, just to be remember, sin x equal to cos x. For differentiation of cos x equal to negative sin x, and differentiate of tangent x equal to secant square x. Then the example given is how you prove that cos x equal to negative sin x. How you prove this part? So you may use the definition. Okay, you may use like this, the definition. Okay, and go through until this part, and then you will get this answer for this example. Cos x equal to negative sin x. Okay, so that is the long way to prove if the question asks you to prove to show that d cos x over dx equal to negative sin x. Okay, using the definitions rule. Okay, that is the part that we need to remember is the trigonometry function part for circular function. Then the last, and not the last part. Yeah, the last part for differentiation is inverse function. Inverse function is what? Macam inverse function yang kita belajar sebelum ni. Kalau fx equal to something, then f, dia bukan f prime, f prime is derivative. F negative 1 is inverse. Okay, so you must remember f prime is derivative, f negative 1 is the inverse function of fx. So let here differentiation of inverse function. So in differentiation also have a inverse function. So let's consider the derivative of fx equal to sine negative 1x. So this part, you assume let y equal to sine x, sine power of negative 1x. Okay. Then you differentiate this y in terms of x. So dy over dx equal to d sine negative 1x over dx. So instead of differentiating y in terms of sine y in equal to sine negative 1x, we can differentiate x equal to sine y with respect to x. So let's say we can differentiate x here where x equal to sine y. Okay. So now you get y equal to negative ataupun inverse sine x. But you get x equal to sine y. Okay, here. Negative 1 is inverse. So you can differentiate this respective into x where dx over dx. So x here is sine y. So d differentiate of sine y over dx. So you apply the chain rule to the right hand side. So we can find that 1 equal to cos y dy over dx. So now sin squared y plus cos squared y equal to 1. Ni rules yang kita dah tahu sebelum ni dalam trigonometry function. Sin squared y, sin squared x plus cos x pun equal to 1. Sin squared y plus cos squared y equal to 1. So cos squared y equal to 1 minus Indahkan, you dekat minus sin squared y. So cos y is 1 minus sin squared y square root of this function. Okay. Since x equal to sin y daripada atas ni, you just change here sin squared y ni kepada x. Then you will get 1 minus x squared. So we also using this y subset of negative pi over 2 pi over 2. So you get this, we cannot take y equal to negative 1 over x because it's more, hence the cost is more or equal to 0. So you only can take y in terms of positive value. You can take the negative value. So you only get cos y equal to square root positive square root 1 over x squared. So it follow that 1 equal to cos y dy dx is cos y is square root of 1 minus x squared dy dx. So you change dy dx here, you will get dy dx equal to 1 over this part square root of 1 minus x squared. So you will get inverse function of negative 1x equal to 1 over square root of 1 minus x squared. Okay. This is how you get the inverse function. Okay, inverse function for differentiation. It is a long way. Okay, it is a long way to get this derivative function for inverse, especially for sine, for trigonal. But what we want to summarize here is actually you need to remember the sixth part. Okay, the sixth part for each inverse function. Okay, before this it is trigonometry function. Now you need to remember another inverse function for trigonometry. So inverse function of sine x, inverse function of sine x ataupun sine negative 1x ataupun you say inverse shift sine x, okay, is equal to 1 over square root of 1 minus x squared for x more than negative 1 and less than 1. For inverse function for cos x, you will get negative 1 over square root of 1 minus x squared for x more than negative 1 and less than 1. So inverse tangent you dapat 1 over x plus x squared. Inverse cotangent x you will get negative 1 over 1 plus x squared. Inverse secant x 1 over modulus x times by x squared plus minus 1. Inverse cosecant x, you get negative 1 over modulus x squared minus 1 square root. Okay, for x more than 1. Okay, quite confusing. Okay, but most probably we use the trigonal function sahaja dalam differentiation. Sometimes we use this part which is inverse function for trigonometry. Okay. Right. This part, this six inverse trigonometry function. Ini bagi dalam slide ni. Okay. Then can we go to some example? Let's say dy over for y equal to sine inverse sine 3x. So using the chain rule, okay, you use the chain rule. Still remember the chain rule? Okay. So y equal to inverse sine x, inverse sine 3x ataupun sine negative 1 3x, okay. Then dy over dx inverse sine negative 1 berapa you dapat? Dekat sini kan? Boleh tengok. Negative 1, sorry sine. 1 over square root 1 minus x squared. Now, here 3x. So 1 over square root 1 minus the x is 3x. 3x squared dot, you differentiate the u part here, 3x. Okay. The 3x lah. Differentiate the 3x, you will get 3 times by this 1 over square root 1 minus 3 power of 2 is 9, x power of 2 x squared. Then you will get 3 over square root 1 minus 9x squared. Okay. Then the second example, this is quite challenging, where y is inverse cos, then you have 2x squared plus 1 power of 10. So let y equal to cos negative 1, which is inverse cos 2x squared plus 1 power of 10. So inverse cos function is negative 1 over square root 1 minus x squared. So you change here negative 1 over square root 1 minus the x value here is 2x squared plus 1. So you change here 2x squared plus 1. Jadi semua ni power of 20. Sebab apa? Kuasa 2. Okay. Because dia punya formula is x squared. So ni kuasakan 2. Then you differentiate this part. Differentiate this part, you will get 4. Okay, differentiate this part. How to differentiate this part? Okay. So the power put here, you get 10 2x squared plus 1 power of 9. Then you differentiate the power the x value dalam ni, which is 2x squared plus 1, you will get 4x. Okay, ada 2 kat sini. Okay. Then this part, leave it first. Then you solve this part first. 10 times 2x squared plus 1 power of 9 dot 4x. Okay, kat sini dia stop sampai sini je, dia punya solution. So your final answer, maybe you can whether you want to simplify ataupun you can leave it like this. Okay, negative 1 over square root 1 minus 2x squared plus 1 power of 20. Or it can be 20x squared plus, okay not you can solve power dulu okay, or you can leave it like this, 10 dalam kurungan 2x squared plus 1 power of 9 dot 4x. Okay, so this is inverse function. So we have some example to compute. Let's say we do this part first. A, inverse cos 3x squared. So you guna rules apa nama inverse function tadi. Kalau cos, derivative of inverse cos function is negative 1 over square root 1 minus x squared. Betul tak? So your x squared is 3x squared. So 3x squared power of 2 nanti. So you tukar kat sini je lah. So negative 1 over square root 1 minus 3x squared power of 2. Kat sini tukar, this is your x. Then you differentiate your x value here. Then you differentiate your x. Same goes to cosecant and tangent. Kalau cosecant and tangent, you can refer back to this part lah. Tangent, tangent dengan secant. Okay guys, I think that will be the last part. The last part. So maybe you can come out with this answer first before we end the class. Okay. So the simple answer will be, apa simple answer ni? So you will get the answer here 1 negative 1 over square root 1 minus 3x squared power of 2 dot 6x. Betul Ataupun you boleh simplifykan kuasa kat sini, you get 9x power of 4 kat bawah tu. Okay, sampai ada jawapan, boleh letak jawapan. Sah juga. Okay. Ni yang mana ni? Negative 6x. Negative 1 square root 1 minus 3x power of 2. Ataupun you boleh simplifykan bawah tu. You akan dapat negative 1 over square root 1 minus 9x power of 4 dot 6x. That will be the answer. Okay. Boleh dah betul lah ni. Okay. Atas ni pun betul jawapan. Mukadim, Sally, Mukadim dengan Ryan. Okay. So you may answer like Mukadim and Ryan, or the answer can be, wait 3x squared. Oh, muka ni I think your answer salah. Siapa salah ni? Wait yeah. Negative 6x betul. Over square root. Okay, dalam kurungan 1 minus, you can get 9x power of 4 kan? Betul tak my answer? X power of 4. Mana you buat power tu? Okay.
Kan shift 6 saya.
Oh, shift 6 Mau pandai. Boleh kan simplify macam tu? Negative 6x over square root 1 minus, okay, thank you. 1 minus 9x power of 4. So you dah simplify dekat dalam tu. Okay, that will be the answer for A lah. B and C you may try. Okay, you may try in by your own. And there will be, thank you Celine, some answer. And then you will be next week. Sekarang dah 1:47, kita habis kedua kan. Okay. Next week kita akan continue technique of differentiation, yang mana technique of differentiation ni more on exponential, logarithm, parametrics, implicit. Yang ni akan ada banyak juga lah yang masuk final exam ataupun test. So make sure you all study for this week. Study more on the rules part, the polynomial, and then the circular function, which is trigonometry part, and also the chain rule of composite function. So for next week, Thursday, there will be technique of differentiation. Okay, kita bakal belajar more on exponential and also logarithm, parametric, and implicit. Okay. So again, differentiation akan masuk test dan juga final. Okay, and most probably the question not very easy, and it will come out more on trigonal part. Okay, trigonal for test maybe more on simple part lah, not really simple, but it is maybe quotient rule, maybe product rule, maybe chain rule. Okay, and final will be much more asking you about trigonometry part lah. Okay. So hope all of you can try to study. Then there will be a class tomorrow, maybe for Dr. Tay, just a tutorial if Dr. Tay want to do. But for my class, there will be a class on Monday, and we will start at 9 to 10. Because our class is not finished yet, the complex number, we will cover more on complex number. And also we try to do some example. So for the tutorial, I will post in eLeap. For my class, it's already posted in eLeap for differentiation and also integration. And for Dr. T, maybe in the eLeap, if you have the tutorial, later I will post in the group, in the WhatsApp group, combined group. Okay, guys. So I think that will be the end of the lecture today. Again, I stop this. Let's stop the sharing session. Sharing slide first. Okay. Okay.
Sir, excuse me.
Any question? Any question? Yeah.
Kalau macam yang pada kelas clash tu, macam mana tu? Yang online, yang recording kena record pulang tu, macam mana tu?
Okay, contoh yang ada kelas clash, because I think it is hard to find the same time for us to do the session kan. So that's why yang clash tu kita bagi kebenaran dia untuk tak hadir, tapi dia boleh dengar balik recording. So the attendant will be they need to mention in the group in the combined group, mention beritahu yang dia clash, give the metric number, then we will enter the metric number. But before we enter the metric number, they need to apa nama, hear back the recording part. So I will post the link. The link will be in the YouTube. Saya akan letak dalam YouTube untuk you all dengar balik dalam YouTube recording part ni lah. Sebab kalau saya bagi in term of cloud Cisco Webpack ni berat sikit lah. So kita make it lebih ringan dalam YouTube. So apa nama, nanti yang tak datang tu boleh dengar dalam recording part tu dalam YouTube. So bila dia dah dengar baru kita letak nombor metric dia balik. So maksudnya attendant dia ada lah. So dia datang, dia dikira hadir dengan dia dengar. So siapa yang dalam ni pun yang hadir ni, kalau nak dengar balik pun boleh dengar dalam recording part. So dia akan ada dalam recording part lah. So no worries lah. Online class kita tak very strict on that, but the attendance we will submit every week to the KPT ya. Sebab online class is dipantau oleh pihak KPT lah. Okay, any question tak apa tadi Siapa yang tanya tu?
Joji tadi.
Oh, Joji. Okay, Joji. Alright, thank you, Joji. Any question from others? Any question? Okay. Is there any question? Okay, kalau tak ada, thank you. So again, for my class, there will be a class on Monday, 9 to 10 a.m. And Dr. Tay, you may confirm back confirm back with apa tu, complex number ada masuk ke test. Complex number ada masuk ke test. Saya tak ingat. Tapi apa nama, untuk kelas Dr. Tay hari Jumaat 4 to 6, I think you need to confirm back in the group yang Dr. Tay tu. Kalau ada you kena, kalau ada kelas ataupun tak ada kelas, you just inform Dr. Tay lah. Kalau mungkin just do kalau tak ada kelas, just do the tutorial aja lah. Okay guys, I think that's all. Thank you again. Sir, paper test 2 dah ada ke? Paper test 2 dah ada. Maksud itu? Thank you. Welcome. Paper test 2. Paper test 2 maksudnya apa? Again test 2 kita buat week 13 Selepas you belajar integration. Week 13 tu baru kita ada test. Test kita buat hari Sabtu. Okay, kita akan cuba buat hari Sabtu. Waktu mungkin pagi atau petang. Itu sahaja. Yang penting you all ada wifi ataupun internet connection yang sangat stable. Dan kena submit borang declaration first. Dan kena on komputer punya kamera. Dan jawab dalam eLeap. Jawab kat kertas, submit dia dalam soalan dalam eLeap, jawab dalam kertas, kemudian snap the pictures, submit dekat eLeap juga. Itu dia punya rules, standard operation daripada pihak unit peperiksaan fakulti dan juga KPT. So kita kena ikut rules tu. Kalau tak, kita tak dikira sebagai exam final online dengan test online. So kita kena buat banyak benda lain. So mana nak dapat borang declaration? Saya akan post dalam group nanti Saya akan post dalam group nanti dengan dia punya SOP. So you boleh baca lah SOP dia dengan borang tu. Kelas saya rasa dia dah submit. Mostly dah submit lah. Kelas Dr. T nanti saya akan post dalam group combine Alright. Okay, any soalan lagi? Ada soalan sebelum kita tutup? Any question before we end our session? Tak ada. Okay, thank you. Thank you. Alright guys. Okay, thank you guys semua yang hadir. Again, terima kasih dan semoga berjumpa lagi next week for technique of differentiation. Okay, Assalamualaikum. You may leave.